Good morning, everyone. Welcome to today's seminar. I'm pleased to introduce our colleague and friend, Jhonathan da Souza, who will share the best practices for repository management and demonstrate how to use the Zenodo platform. This session will help us to improve your research workflow while ensuring efficient data and preservation accessibility of your work. So enjoy the session. Jhonathan, up to you.
Oh, thank you, Jordi. Hello, everyone who don't know me yet. I am Jhonathan, and I'm working here in IQTC with some repository practices in the beginning, and I'm also investigating some quantum computing calculations with quantum chemistry. But today, I'm gonna talk to you a little bit about repositories and backup practices, and in the intention to standards to make a standard for the institute, and where we can share our files and put our files on a common repositories for all the institute. So I'm gonna share my screen now, and I'm gonna present something. See, Georgie, I need that you accept, please. Thank you so much. Yes, compartir. Okay, so let's start. Uh, my presentation will be separated in four main topics. I'm gonna do an introduction about the topic. I'm gonna talk a little bit about the IQTC profile in the last year that we analyzed some data about repositories and backups. And also I'm gonna talk a little bit about good practices related to storage and other repositories stuffs. And also, I'm going to talk a little bit about the repositories to show to you the options that we have to put our files on cloud and online repositories. And I'm going to show to you also how to upload a file for Zenodo in the end of this presentation, because Zenodo is going to be our central repositories since now. So let's go a little bit talk a little bit about data in computational chemistry. As we know, we deal with a lot of data because computational chemistry generates a vast amount of data. In this set of data, we have inputs, midputs, and outputs. We have molecular and solid structures, energy profiles that we can generate from calculations. We also have some electronic properties like molecular orbitals and energies. Also molecular dynamic trajectories for those who works with classical mechanics. And we also have reaction pathways and mechanism. Of course, we have other kinds of data, metadata that is related with computational chemistry, but I just brought this as examples of the most generated, the files that are most generated. And in this sense, when we have a lot of data generated, a lot of files, the most common storage practices are the external hard drivers, as all of you maybe use it. We use a lot of external hard drive it, and also pen drives, flash disks to storage our datas. And also some people likes or had the custom to use local storage and also servers. These are common types of storage that we use for safe data and in general. But this kind of system that can storage data can fail, can have breaks, can have errors. Also can be full in some point because the vast amount of data that we generate sometimes cannot be storage in these devices because they have limited capacity, and also all the times you have to increase this capacity and so on. So because of this, we believe that web-based repositories are crucial because we have like preserving the continuity of research, because once you have the data on the cloud, on the web-based repository, you can continue develop the research, and you can continue looking for the results and work on the data, and also maintaining a real live record of scientific process, because as our data are in the repository, we can have like a reliable recorded of this. Besides allowing reproducibility of other researchers, because when we share this data on online repositories, you give the opportunity to other researchers to make a reproduction of your data, because they can access, they can read, they can analyze your data, and can also reproduce it. Besides, also we have preventing accidental lost data by several reasons. When your hard drive breaks or accidentally falls and you lose your data, so if you have the data on the repositories, you don't have this possibility to lose this data for sure. Furthermore, we have quickly share with other collaborations. If you are doing a research when you need to collaborate with someone abroad, the online web-based repository is a good option, because you can quickly share. The other ones can see your data, can work on it, and also can do some modifications on your data, on your results or other files. And also, web-based repositories means a central storage for institutions and other companies, institutions, and other kinds of groups of people. And this also allows us to do some metrics, so we can do some
Jhonathan,
scientific
sorry.
metrics.
We don't
Sorry?
see your slides changing. We can only see the first slide. I don't know if you're changing your slides.
Yes, I'm changing.
We
Oh,
haven't been seeing, sorry.
I'm sorry. Oh, I'm sorry. Let me see if I can do something. I'm gonna share again. Uh, just a moment.
Tienes que no duplicarla, que tienes la pantalla
Ah, tiene una pantalla duplicada. Ah, vale, vale, so, yo saco eso. No, será más duplicado,
Sí.
vale, perfecto.
A mí me pasó.
Lo mismo, vale, tranquilo.
Okay, let's try.
Okay, let me check. Just a moment, guys. I'm sorry for that technical issues. Pausar. Compartir. Compartir. Eh,
Ahora sí,
ahora sí.
ahora sí.
Perfect.
Vale. Un momento. So let's continue from here. So I was talking about these topics. Just to remember, web-based repositories can preserving the continuity of the research, maintain the reliable record of scientific process, also allowing reproducibility by other researchers, and preventing accidental loss of data by several reasons, quick sharing with collaborators, and also give the possibility to make some metrics with the data and metadata that you can generate during the research. So let's move on. So web-based platforms are very important, as I talked to you just now, but now let's see some examples of this. First of all, we have electronic laboratory notebooks that are integrated environment for storing file alongside notes. So if you need to take some note about some result, electronic lab notebooks is a good option. So we have these examples as eLab, FTW, and also ChemMotion are two platforms that provide electronic laboratory notebooks to store data, to put some notes on data. Also, as another example of web-based platforms, we have molecular databases. This kind of databases store and classify molecular structure and properties. And as an example, we have like Cambridge structural data, and also Protein Data Bank and PubChem are examples of molecular databases. Also in this field, we have web repositories that are some places where you can virtual places where you can store codes, data sets, and you can also do some visualizations of the results and other kinds of results that are inside this kind of web repositories. And as example, we have Nomad, IOChem, and Zenodo that was, I think you already know them, and some of them already use it. So let's move on. Once we talk a little bit about the introduction about the data generating computational chemistry, I would like to talk to you a little bit about the IQTC profile of our storage and our repository practice until now. So about the data storage, I put some graphics here to show to you the amount of data generated in the last year. As you can see on the graphics, we have like the months during 2024 and the amount of storage used by the data that was generated during this period. As we can see here, we have different groups that have different profiles of uses of the storage. But one interesting thing that we realized is that in the last 3 months of the last year, we had almost full capacity of our storage. So we almost reach our limit of storage in IQTC, and this of course this is a warming thing because we need to think some strategies to storage more and more data once our researchers are generating more and more data a long time. So also about the repository and backup usage. About the repository, this is the profile of the IQTC. As we can see here, we have a diverse profile, and it's not central because the whole community of the IQTC is not putting the data just in one repository. And we also have a non-high percentage. As you can see here, we have 21% of the institute that does not use some kind of repository. So this is a warming thing. Also, this is a worry because this could lead in loss of data, and this is bad for the institute because we want to provide some place to storage all of this data and some strategy to all the community start to use it and had this as a standard to use it. So also about the backups, as we can see here in the graph, we have most of the community using external hard drives, as I said in the beginning, and we also has a risk. This is risk because external hard drive can generate some loss of data, can be broke, etc. And also the backups are not central. And also we have a non-high percentage. As you can see, 18% of the institute doesn't have backups, doesn't have a strategy for backups. So this is important to think about it because we aim to do not lose data. So once we said that, how can a research institute enhance efficiency in data management and storage? Of course, we are talking about theoretical and computational chemistry data. So the answer for these questions relies on two main strategies. One of them is had good practices, as we're gonna talk a little bit about now. And the other one is to use repositories that we're gonna talk a little bit later in this presentation. So talking about good practices, first of all, it's good to have an organization of folders and files, because once we have this organization, it's possible to find the data so easily. It's possible to share this data with some standard features. So the first strategy is hierarchical folder structure. So it's advisable that the folders and file names are created with some kind of hierarchy. So with this, we can, as an example, we can organize the data with some folders and some informations that is important for all of the development of the researcher. So second, we should use some consistent naming conventions. So it's important to create a reasonable nomenclature system when we use descriptive and standardized file names. For example, as I'm showing here, you can put some molecular name, method, run, property that you are investigating. So this is important for the share of the data, but also for the people that are doing the research, because it's easy to find it, it's explainable. The name of the file explain itself. This helps a lot. For example, here we have a nomenclature system for different kind of files that related with DFT calculations. As you can see here, we have like a name that is the molecular file name, and each one of these letters means something. For example, if in the position A, I put some number 1, it's gonna mean something. If in the position B, I'm putting some number, for example, number 1, it's gonna mean another thing. So with this, you can create a nomenclature system that is easy to identify. For example, in the name here, you have like abbreviation for the compound name as is shown here. So this also is helpful when you can organize your files. And the last strategy for organized files and fold is metadata documentation. This is most of the times is included with a readme file, when we can describe all of the informations that it's related with your research and with your data that is inside some fold or inside some directory. So another strategy to manage data is frequency of backups, because as soon as we are generating a lot of data and new data, it's important to make a backup, to have a safety copy of the data, because eventually if something happens with your data, you already did your backup. So the frequency of backups include daily backups when we do automate backups for critical and frequently updated files. This includes raw simulation data such as output files, log file, trajectory files. Also intermediate data that includes partially processed data or results from intermediate steps in longer run simulations, and also script and code modifications, because if you do some modifications in a code, in a script, is important to back up as soon as possible to do not lose that modification. Sometimes some modifications are crucial for the development of some software, some data, etc. The second one is weekly backups. These weekly backups include different files. Could be included final calculation results, such as PDB, XYZ, JSON files. Also, project documentation and notes, which include research logs, lab notebooks, and project reports. Weekly backups will help you to maintain all of the documentation of your research saved, and generating a copy of this. It's important because when you need to send documentation, a report for some agency of money, you have this already done. Also, job scripts and configuration files are important to backup weekly because these files contain configuration for running complex computational jobs and simulation and other informations. And we have also offsite backups that are backups that are not online, and you can put this on hard drives and etc. And also can be a safe copy for your data. And this includes research publications and presentations, final versions of projects, papers, articles, and other ones. Master databases or data sets that are large, non-replaceable data set like experimental results, reference data, and well-curated databases, and also final project archives. In this point, you can compress all of your data for a finished project and do a backup of this, because in some point in the future, maybe you want to revisit this data, and if you want to do it, you have all of this saved and security. So in this sense, usage of repository is also a strategy, a good practice for storage data. So we have like different kind of repository. The first one of them is institutional repositories, where you can have long-term preservation of the data. You have also in the institutional repositories, you can add some branding for visibility. For example, if you work for some company or for some university, if you use this kind of repositories, you can use the brand of the institution to foment, to spread the visibility of your research. And also you can count on compliance with institutional policies that helps you to better practice about the data and about the publishing your researcher. In Barcelona, in Universidad of Barcelona, we have two examples: is the CRAI and the deposited digital, that you can send data, you can send some researcher for repositories like this. And also we have open repositories that are global accessibly and allows collaborations, increase the impact and citation of researcher, because the open repositories can be viewed by other researchers on the world. So they can looking for, they can cite your researcher, because they can find your researcher in this kind of repositories. And we have the facilitation of the open science and reproducibility of your research that you are spreading. As an example, we have Archive and ChemChive, that are platforms that allow for publishing papers and publishing researchers without, of course, they don't have like peer review it, but they allow you to upload your research there. And we also have private repositories that include confidentiality and security for that kind of researcher that needs to be confidential. And also the access are controlled if you need to control the access of your data. And sometimes you have customizable storage solutions, because private repositories can offer to you sometimes some specific characteristic for your data. And in this sense, we have OneDrive and GitHub. They are private repositories, and we can control the access of the data. You can share with who you need to share. So, talk a little bit more about the good practices. Of course, I have to talk about fair data principles. This is a standard in our community, in the data community in general, and was first proposed in 2016 by Winkerson and co-workers. And in these papers, Winkerson showed to us different principles of repositories and data sharing when we talk about scientific research. And after that, we have a deep interpretation of these principles by Jacobsen and your team that will talk to us a little bit about a little bit more about how to interpret these FAIR principles. FAIR principles are, as I'm showing to you here, four concepts that's important when we deal and we treat data. As we can see here, we have the abbreviation. FAIR is abbreviation for findable, accessible, interoperable, and reusable. So we're going to talk a little bit more about each one. In the sense of findable, data and metadata are assigned a globally unique and persistent identifier. So this, it's, for example, we have the DOI identifier. That is a example of persistent identifier that you can look on the website. You can look for on the internet for this research, and you can find it with a code, with a specific code that it's gonna point directly to your researcher. The second FAIR principle, findable principle, is data are described with rich metadata. So it's a good practice when we write a metadata with a lot of informations. So to have a good practice, it's good to make a rich metadata for your research. Also, metadata clearly and explicitly include the identifier of the data they describe. To be findable, the metadata should include the identifier that was generated. This persistent identifier should be together with the metadata with the research that you are developing. And we also have data and metadata are registered and indexed in searchable. So to be findable, all of your research should be registered and indexed to be findable in any platform that is indexed. As an example, we have Zenodo, as I'm showing here. Zenodo is an example of findable storage. In that platform, you can have your researcher findable. The other one is accessible. Data are retrievable by their identifier using standardized communication protocols. So you must be allowed to access the data and all of the metadata about a researcher easily with standardized communication protocols. And the protocol is open, free, and universally implementable. So this is to make more accessible your data. So the protocol that you need to access to retrieve some kind of research should be open, free, and universal. Also, the protocol allows for authentication and authorization when necessary. Because if you are accessing some data, some researcher, and sometimes we ask if this data, this research is authentic, so you can, with this practice, you can authenticate it, you can be authorized to access it when necessary. So authentication is also an important thing when we talk about FAIR principles. Metadata remain accessible even when the data are no longer available. So when we talk about accessibility, the metadata should be there even if your researcher is not there anymore. So it's important first have a metadata well described, and this metadata should be there all the time. As an example, we have EOCam, the BD, that is a platform where accessibility is ensured, is guaranteed. Next one is interoperable. This principle, the data use a formal, accessible, shared, and broadly applicable language for knowledge representation. So your researcher should use some kind of accessible language, some kind of formal language that everyone can operate inside the data and the metadata. And data use vocabularies that follow FAIR principles. So this point, this I2, interoperable 2 principle, talks about that the vocabulary that is written, that use it in some kind of research, should follow the FAIR principles. Also, the data must include qualified reference to the other data. So if you have some kind of researcher on a repository, this researcher should include a very qualified reference for other data that you are using. If you as a researcher are using a data for other researchers for other kind of investigations, it's important for you to know what's going on, to know from where this kind of data came from. So it's important to have this kind of references qualified and well described. And a good example of interoperable principle is the protein data bank, because they use the PDB file that is possible to interoperate between the softwares, between other kind of files. So protein data bank is a good example of interoperable principle. The last one is reusable. Of course, this is related to usage of the data. So data are rich describer with a plurality of accurate and relevant attributes. So when we well describe this data, it's good to other researchers reuse this, and also related to reproducibility. And also data are released with a clear and accessible data user license. So for that people that restrain your research, it's good. It's a good practice to use a license for give the opportunity for other researchers to use your data if it's necessary, of course. And also data are associated with detailed prevalence. That means that if you detail all of your researcher, they're gonna prevent us a lot of possibility to be reusable for other researchers. And last, data met domain relevant community standards. As we are talking about standardization, this is a good point, because the domain relevant community, of course, you're gonna establish some standards, some patterns. So this, it's good to follow this kind of standards, because everyone it's gonna be allowed to reuse your data, of course, if it's possible, if it's necessary. And a good example of this is the Cambridge structural databases, because they have all of these points that is listed here. So it's a good platform to reuse data from there. Good. Moving forward, now I'm going to talk a little bit about the repositories. I'm just going to show to you 3 types of repositories, and in the end, we're going to compare, and we're going to talk a little bit about Zenodo repository. And yes, let's do it. Before talking about repositories, I would like to share to you the Fair Sharing platform. This platform, it's a platform where you can looking for some kind of repositories. This is a platform where most of the repositories are assigned and indexed. So if you want to know some characteristic about some specific repository, you can look for these repositories inside this platform and see what kind of characteristics these repositories can provide to you as web-based repositories. So it's very interesting. You can look for all of them. Zenodo is there, EOChem is there. So in this platform, you have this kind of informations. It's like a central for finding some repositories. And okay, after that, as we saw in the IQTC profile, some researchers of our institute use the EOChem BD. So this platform is a very good platform for computational chemistry and allows to upload a lot of files and files related with this researcher field. And also, this repository has some kind of, as how can I say, some kind of facilities, some kind of tools for specifically for computational chemistry. So it's a good one, is an option, it's a good option to use for sure. We also have Nomad repository that is more focused on material science, is more for solid state and compounds that are related with solid states. It's a little bit similar to Materials Project for those who know this platform. So it's very close to them and it's focused on this, but it's also available for usage of computational chemistries also. And we also have Zenodo platform. This is a European Union repository, and it was created by the AIR project, a project from European Union also. And in this repository, you can put any type of data. You have a lot of tools, a lot of facilities that can treat, that can include metadata in your researcher. So this is a very good option. And us here in IQTC, we decide to start to use this kind of repositories as a standard for our institute. And so let's see a little bit about the pros and cons of these repositories. There are a lot of information here in this table, but I'm not gonna I'm not gonna talk about everything. I'm just gonna show to you that we have EOChem here, Nomad and Zenodo here. So we have different kind of characteristics here. We have data type support, fair compliance, storage capacity, cost, DOI assignment, collaboration, integration. And as we decide for Zenodo, we have very good points here. For example, cost, we have free for all users, and DOI assignment, we have automatically assigned DOI for all uploads. I'm going to show to you because this is important, because if you need, as we want to follow some fair principles, it's important to have some DOI for our data that are uploaded. And also about the integration, we have integration with ORCID and also GitHub that you can integrate your data with these platforms. And another good characteristic is about the storage capacity, where we have unlimited store capacity for Zenodo. So you can upload a lot of files that you want, different types of files. And for us, this is important because we have a diverse community that generate different type of data. So on the Zenodo platform, you can store every kind of data, and this is very good for everyone. So I'm gonna send to you this slide so you can look for these characteristics later. But yes, we have a comparison between them, and as I showed to you, all of these three are good options to storage data. And I'm just going to show to you that now we have a IQTC community at Zenodo, as is shown here. And I'm going to show to you a little bit more about the Zenodo. Yes. Let's show a little bit more about Zenodo. Just a moment. Zenodo. Here. here. So I think it's still sharing. Yes. So as you can see here, we have the Zenodo platform, and when we want to upload some file, it's very easy. You just click on new upload, and then the platform will allow to you to upload a file. And also here you can insert some basic informations. You can have a digital object identifier that is unique, so you can request for Zenodo to assign to you a DOI for a publication for a researcher. You can describe the
try to
research
share the
type. You
screen.
have different categories for put
Jhonathan.
your data. You also need to put a title. Also, sorry, it's not sharing. Just a moment again. Yes, now it is compartilhar. I think now it's sharing.
That's correct. Thank you.
It's sharing now? Yeah, sorry for that, guys. We are having technical issues here. Sorry. But I was saying that here it's another platform. So if you want to do a new upload, you just click on new upload, and here in this page, you can upload your file or drag or drop your file here. And you can fill a lot of metadata. As we talked before, metadata are important for a lot of reasons. And here you can request a DOI, a unique DOI from Zenodo. You can choose a category for your data, as we are seeing here, a lot of different kinds of categories. You can put a title, you can put a data, a description, a license if it's needed. And also you can put some recommended information that is more metadata. Here, add contribution, language, keywords and subjects, data, etc. Also, you can put some funding, the agency that is funding your research, and you can add here. You can also add some alternative identifiers if you have if you already have a DOI assignment, other identifier. Also, you can put some related works. If you have some related papers, related data, you can also assign here, put here. References, you can put references here also. Softwares, publishing information, and etc. Conferences, domain specifics, etc. After you fill all of this data, you can choose to publish here. You can put something public or restricted. If you don't want, if everyone see your research, you can put restricted, and only you is gonna be allowed to see your data and your metadata. So after that, you just click on publish it, and you have your data published. So here we have some examples. I already uploaded the repository practices report that I prepared for these presentations, and I also put here a repository practices for a tutorial for Zenodo platform. So here you can download the tutorial for Zenodo, or you can download also the repository practice report that I will prepare for this presentation. Everything that I talk here, it's explained better there, where you can read, you can think about it. So Zenodo, it's a good platform, and for us is the best one, considering our necessities. So okay, I'm gonna return for the presentation. Maybe I have the last slides. Just a moment. De pantalla. Yes. Here. Here. Yes. Compartir. Yes. Perfect, perfect. In the end, let's go to the end. So, yes, as I was saying to you, we have a IQTC community in the Zenodo repository, and I would like that you use it. You can put your files there, you can upload your data, and you can, as I showed to you, if you don't want to share in principle for all the community, you can put your data as restricted, and only you and your group is gonna have access. But in principle, we want to provide some standard practices and also to foment this kind of practices, to put the data on web repositories. And then some only final remarks. The increasing complexity and volume of data in computational chemistry require robust, efficient, accessible data management practices to support modern researcher needs. Proper organization of files as regular backups, engaging with institutional or open repositories are essential steps in effective data management, and these also promote collaboration and safeguarding research outputs. Also, platforms like EOChem, Nomad, and Zenodo play a key role in storing, sharing, and reusing scientific data while ensuring compliance with FAIR principles for accessibility, interoperability, and reusability. And also the integration of AI tools in community-driven platforms like Zenodo, along with best practices, will foster innovation and ensure long-term value for global scientific community. And I put here the link for the report and for the tutorial of Zenodo. If you want to download it, it's you only just click on the link. It's gonna be directly for the page of Zenodo where these files are uploaded. Yes, so thank you for the attention and thank you so much. If you have some questions, you can ask. Eliseu. Eliseu. If you have some question, guys. Thank you so much, Miguel.
Very, very clear explanations, Jhonathan. Thank you very much.
Sorry, someone is talking, I cannot hear.
No, I was just telling you that thank you very much, Jhonathan, for this very nice talk and very useful. Thank you so much.
Thank you, thank you. See? Thank you, everyone.
Hello. No se escucha, ¿no?
Sí, se te escucha,
Ah, vale, es que volví a hacer la... No
pero no
si
sé si
está-
ha sortido el Jonathan.
Sí, yo estoy oyendo, sí.
Ah,
Hello.
Sí,
I,
sí.
I have a question. So if
Yeah,
we
yeah, yeah.
select if you select restricted visibility first for uploading your repository or your data or something, can you then later change it to publicly visible? You know that?
Yes, you can change it.
Okay, okay. Okay, so that was it. Thank you.
I
Thank you.
I have also a question. So here, apart from storing data, there is some kind of so that you can visualize the results. For instance, as in IOChem, that you can visualize orbitals. So here you can only store data, or there is some utilities that you can also visualize your results somehow.
No, so in Zenodo, you don't have tools for visualize the results, just for stored.
Okay.
Mensaje nuevo. Gracias, Georgie. Okay, guys, I would like to thank you again, everyone. If you want have some more questions, you can ask for me on email also. And also, if you want to talk to me in person, I am on the office all the time. So if you want, thank you so much, guys.